Welcome to my fourth video in my ActionRPG series for Unity. And in this video, we're going to take a look at obstacles that can be affected by the levers, which allows us to open or close pathways based upon some states that get set either by levers, by defeating monsters. You can generalize it in a lot of different ways. And so that's what we're going to explore. Now, in this example here, I've already started crafting a parallel set of switches just to show you that the blue switches aren't necessarily linked to the red switches. Now, the red switches don't control the red blocks yet, but I put that in there just to demonstrate that each set that we construct operates on its own different circuit, even though it's all stored in the same data dictionary. We're going to be able to access. We are able to store multiple switch states, and in fact, you can store as many as you wish to name. And it doesn't even have to be a switch that sets these. The death of a boss monster could even do this, so you don't have to do it with a switch. Anyway, so let's start by making these magic blocks. I figured the magic block is a pretty quick and painless way to demonstrate this, and then I'll demonstrate it with using a more normal looking locked door. So to make a magic block, I'm just going to start with an empty object here. I'm going to call it magic wall underscore blue and reset its transform. And then I'm going to give it a rendering sprite renderer. I'm going to give it the magic block bright blue. That's the wrong color, I believe. I guess that is the right color. And then so we've got magic wall blue there, but we want to use the animator. Now I did already load an animator for this, and so we can just go take this inside of animation environment magic walls. There's already an animator for magic walls blue, and we could just take that and drag and drop it onto the object, and it will attach an animator component that I've already created when we imported all this stuff back in the first set. And you can see that if you do so, it will be animated. And so we can have a wall there, even though that's not really truly a wall. Okay, so to make it into an actual wall, and as far as the animator goes, it should already be set up. There's not much you need to do. The animation is really pretty straightforward. It's just a sequence of the first image, the second image, the third image, the second image, because it's cycles. So it looks like it's kind of pulsating. And I just have them evenly spaced out. It's going to take 4 frames, but because I'm trying to do 2 ticks in between, I need to have that same frame there twice. So that was 1, 2, 3, 2, and then that's another 2 to extend it. That was the built-in animation that you imported, and there's the animator, so not super exciting. And that's actually the same exact thing the red ones have. Did that just to save us some effort, so we don't have to go and make it ourselves. Now for this magic wall blue, we need to give it some of its components to block the player. So physics 2D box collider. And it looks like the box collider is properly sized. I don't really need to change anything else there. Physics 2D rigid body. I'm going to make it static again so it doesn't move around in the world or do anything. I'm going to minimize those once I'm done with those. And then at this point, we're pretty much ready to begin creating a script for it. Since it now properly blocks me. But we want to be able to have it get affected by the switch. And so, time for us to start setting that up. It is worth mentioning that we're going to talk about the tags and all this stuff in a little bit so that we can have a little bit more control over it. I am intending to make it a doodad, technically, so that we have the doodad's ability to set its stacking layer, its ability to block flying projectiles. So it actually kind of makes sense that we're going to tag this thing as a doodad eventually. But let's make the script for it. So scripts environment. We're going to expand that up. And we're going to call this create a C# script. It's going to be called Magic Wall. Now, to be fair, it is called Magic Wall, but anything could have this applied to it, because all it's going to really do is just make the object disappear when the switch is activated. If you wanted to get fancy, you could try to make a gate that animates going down and then does all this stuff. But let's take a look at how we've named some of these things. So I'm going to take this part out of lever. So it's going to also need access to that dictionary, because that's going to tell it the state of the switch. It will need a lever name. Now, we're free to name this something else. It doesn't have to be called lever name, but we could just, it needs to be something like that. That affects it. And then one more that I think is kind of useful is inverted. And so does this work in opposite of the state? So an inverted wall would basically be there when the switch is on, but not there when the switch is off. So it's opposite of the normal behavior, which is actually kind of a key component in a lot of these like switch wall puzzles, is when you hit the switch, some walls disappear, but other walls reappear. And so some of the components that we will need. All right, we're going to need the sprite renderer. And then we're going to need whatever collider it has. So I'm just going to call it a collider 2D, because I don't know if it's a box, a sphere, what kind of, or polygon, called my collider. And that's really about all we need here. So during start, we have to initialize everything. So sprite renderer is set to the get component of sprite renderer. And then the collider, my collider, is going to be set equal to get component of whatever collider 2D we have, using that polymorphism to do whatever collider we need. And we're not going to need to do anything else, because we're going to actually handle the state of the wall inside of update. So if the wall needs to be invisible immediately, that's going to be done inside of update. All right, so let's make this a little bit easier on ourselves. We'll create a Boolean called state, and we're going to get that from data Boolean, and we're going to access the lever name. But since we're accessing our data dictionary, we need to make sure the data dictionary is functional, which is a call to data dictionary.initialize check. So we just got to make sure that it exists before we try to do any of this. Which does lead me to kind of think this could be dangerous, because we don't know what the state's going to be. So because let's say we have a block and it doesn't have a lever here, we actually don't know if this is going to call it before the switch calls it. Now I know the switch does it during start, so let's do this in a different way. As much as I want to do it that way, I think that is kind of dangerous. We're going to use the try get value, and we're going to try to get the lever name, passing it into states. So kind of make those variables really clear here. State is going to get updated right here to whether or not, to what it is. So if it's not found, it defaults to false, which is fine. And then whether or not we found it is going to be stored here, because this method returns true or false based on whether or not it was found. So we will know if we found it, if we want to do anything with it. Okay, so, and then we'll just do if is inverted. And that's to make it a little bit easier than having another set of if statements to figure out what to do here. So if state is true, meaning the switch is activated, the block should disappear. So if that's the case, then sprite renderer dot enabled will be false, and my collider dot enabled will be false as well. So if the switch was not activated, then the blocks will remain there and continue blocking you. So we're going to save that for the magic wall. And so that's just the basic wall appears if the switch is not hit, and then when you hit the switch, the walls will disappear. So I'm going to switch back to Unity, and hopefully you've managed to grab all that code. Let's add some comments here. Okay. Hitting save on that. And we'll return back to here. So magic wall is going to need the magic wall script. And the data dictionary will need to be attached. Found under scriptable objects, data. And the lever name, well, we need to check to make sure it's named the same thing as the blue lever, which is just called blue lever. And this one we won't do it. We'll set up one where we do some inversions with it. And then we wanted to attach the doodad script as well. And so the doodad script, I don't need to change any of these offsets, but it will give me the ability to choose if I want it to block projectiles or not. So I'm going to tag this as a doodad as well. So we've got a magic wall script and the doodad script attached. Then we want to turn this into a prefab. Just drag and drop it down into environment. And now we have a replicatable prefab wall. I'm going to update my red wall real quick since I did not have those scripts. So attach the data, and this will be called red lever. And it also needs to be a doodad. Oh, but I already put the doodad script on it. Well, and the reason why is so like we can make these red ones block projectiles, the blue ones won't, just so we can demonstrate the fact that it would be beneficial if you wanted to make these things have the ability to block projectiles, so you couldn't shoot over them, for instance. Okay, so we got our animated walls here. This one does not block projectiles, this one does. When we hit the switch, disappears, block goes away, hit the switch, those disappear. Now I can travel up here. I turn the switch back on just to annoy the monsters. Really should make that fireball override their projectiles. And so our switches are working. So let me just throw a few inverted walls in there so we can demonstrate the inverted effect. And then talk about like duplicating the walls to make life a little bit easier. So if I'm going to take this wall here, and maybe I'll put it somewhere like here. If I wanted, my recommendation for handling these walls gracefully is keeping them to a factor of 0.5. So this would be negative 0.5 and this should be 8.5. And then if you wish to duplicate them, while you have the wall selected, if you hit Control D, it'll make a copy of it. Then if you continue to hold down Control, it actually drags it, effectively snapping it to a grid. And you can see how it's behaving there. And so I can use those to kind of create a blocked off path right there. And maybe I want to move my switches up there now. So if I put this switch here, maybe I'll put this, oh, that's going to block them. So I need my other switch here still. And then let's play around with doing some like inverted blocks. So I've got this set of blocks right here, and I'm going to make them all is inverted. And so those ones are going to be backwards blocks. Probably would be worth doing some kind of doodad or some kind of like debug gizmo to indicate that those ones are inverted blocks to make it easier to develop. But with my two switches here, you can kind of see that they operate on different channels. That this red switch has no bearing on those blue things. And if I walk off the screen down here, there's no red switches in this stage, but because it's stored in the game controller, it does retain the state. And those monsters don't come back. So when I hit this, you can see that this opens. And then when I hit this switch, it lets me go through. So kind of doing like a little bit of like an airlock puzzle. Now for the last thing I want to take a look at is I just want to kind of put a door right there just so we can see this with something other than just doing those blocks. So this is going to be designed for like just kind of taking a look at like locked door type of stuff. But effectively the switch, the block stuff is done. So the only thing new in this video will just be me creating another type of kind of locked door thing. And so if you wanted to skip the rest of this, you will not miss anything new. The next video will start to cover some of the game over states. So let's quickly just kind of start throwing together some kind of door there. Now you probably should have from way back when in our doodad creation, maybe some of these like locked door things. And if I wanted to bring one in, maybe I want to put like a little locked door right there. Fortunately, the tree is kind of in the way. And we've got it right there. So this locked door could actually basically be like one of the switches. So all we've got to do is kind of set up the same pieces to it. So it needs to have whatever kind of collider we want to give it. So I guess a box collider. I'm going to turn it into a doodad. And then it needs a rigid body. I'm going to switch it to static so we cannot push it. then I think all it really needs now is just the scripts. So if we go to environment, we can add the magic wall script, and we can add the doodad script. And so that should handle all the things that it's going to need. And we need to attach data. And to save the trouble of making a new lever chain, well, you know, we could just do it real fast. So this is good to see how to break a prefab too. So like if I have a blue lever and I want to break its prefab dependency, I can bring it into the world where I want it. And then if I bring it, so I'm going to rename it first. Let's just call this door. Its lever name is door lever. And I'm going to take this object here and bring it down into this environment. By doing so, it asks if I want to create a variant, which I don't, or an original prefab. If I choose original prefab, it breaks the dependency from the previous, meaning this is a whole new prefab set now, which could be useful if you make a magic wall or switch and you want to quickly start making another one without having to redo all that. Anyway, so we've got this switch here. Let me see if I've got any good switch graphics for it that I haven't used yet. So textures. And I mean, I guess this is the... Geez, you can get all kinds of weird with this. So... you don't even have to use switches. You could just use like a sign that switches it to a read when you use it. But let's take a look at switches. So maybe I want to take this one, which is 4, and that one's 28. So I'll just use those. So its normal sprite is that one, and the script that it needs a 4 for left and 28 for right. Now when I've changed those, I can just go to overrides and hit apply to tell it to change it down into the prefab, which we made a whole new prefab for. And this is called door lever, and this is the door is called, needs to be on door lever. And so when we hit this switch, the door should disappear and we should be able to walk through and go to the next zone. Those skeletons. So now this door is preventing me from going into the cave, but a player who spots this lever can hit that and the door now opens. Now there's no door here, and we could probably have inserted one so that when we come in, this door could have been locked if we wanted it to. Now the door's locked. So it gives us a lot of flexibility in our level design to have this, because you can also have a boss monster trigger this effect and this door react to it as well. So there's nothing really tied to the fact that this is a switch doing it. All you would have to do is replace like this mentality where I'm updating the data dictionary. You could have a boss update this. And you could just have it say like lever name is true, and then that way you could go have like a door open based off of that. You wouldn't even need all this graphical stuff. You just literally need this one line here when it is defeated to add this piece of data to the Boolean chain. And so that kind of really wraps up this magic wall business. Oh, my cat's sad. He wants more magic walls. Or maybe he wants me to make a boss monster. Do you want a cat boss? Maybe? I don't know if that's a yes or no. But anyway, he wants some attention, so I think this video is pretty good done here. The next videos we'll start to look at kind of defeat and restart, and then from there's a lot of the optional things like different puzzle mechanics, terrain, hazards, and so on. So thank you for watching, and enjoy making switches and doors.